looking at problem number 20 on our review for test 4. This is an equation, and we have to say what values that we cannot get for an answer. So we look at our denominators to see what will be excluded. So we cannot get 2 because that would make a 0 in the denominator. So we're just going to throw that away. So x cannot be a 2, and x cannot be a negative 8. Right? And then at the end we'll make sure we did not get those answers. Right? For this problem you could either find the LCD, which will be both of those, and multiply by it, or you can do it as a proportion. I will do this one as a proportion so you'll have an example of each. So a proportion only has one fraction on each side of the equal sign. When you solve a proportion, you multiply across the equal sign on the diagonal. So we have 3 times x plus 8 equals, and we go across the other direction, 4 times x minus 2. And then we simplify and solve. So we have 3x plus 24 equals 4x minus 8. We will isolate the x, so I'm going to subtract this 3x. Give me 24 equals x minus 8. Add an 8 to both sides, and that will give me x equals 32. I did not throw 32 away. I threw away 2 and negative 8. So my solution is 32. For problem 21, we are going to find the LCD and multiply all the way across by it. So first we have to factor this denominator to see what the LCD will be. And these are both going to be plus with A's, and a 5 and 1 will work there. This a plus 5 is also covered in that one, and this will give us the same. So our LCD is going to be a plus 5 and a plus 1. We're going to multiply through by that on the top. Also, our excluded values. A cannot be a negative 5 or a negative 1, because those would make zeros in the denominator. So I'm going to multiply everything by a plus 5 and a plus 1. You use the entire piece. And this is times 1 over a plus 5. I'll come back and clean up. And then I'm going to use a plus 5 and a plus 1 times 1 over. I'm going to go ahead and keep this in factored form. It's going to cancel anyway. Alright, and then I have my equals, and I'll do the a plus 5 and the a plus 1 times 2 over a plus 5 and a plus 1. Now we're going to clean up, and we'll see what all cancels. So in my first term, my a plus 5 will cancel. Leaves me a plus 1 times 1, which is just a plus 1. In my second term, the a plus 5 cancels, the a plus 1 cancels, so all I have left is a plus 1. Equals, on this side, the a plus 5 and the a plus 1, so I have a 2. So here I have a plus 2 equals 2. Subtract 2 from both sides. So a equals 0. It's okay to get 0. 0 is a number. We did not throw 0 away. We threw away negative 5 and negative 1. So our answer is 0. For problem 22, again, we do have an equation. That's what you want to spot first is your equals. It has fractions, so we're going to clear those out. we need to figure out the common denominator. And so we need to factor to see what this will be. We have an r in there that's common, so we'll take it out as a GCF, and that will leave r minus 3. This one is the same, and this one has an r minus 3. So you have to take every kind of piece, and you take it from the one where it occurs the most. So I need an r, and I need an r minus 3. That will give our LCD. Also, because you have variables in the denominator, you have to see when any denominator would be 0. So you have to throw out those values. So our r cannot be, from this first one, it cannot be 0 from this r that's by itself. And from the other piece, it cannot be 3. If we just set r minus 3 equal to 0, we can solve. So r cannot be 3. And then we will check that at the end. All right, now I'm going to multiply through on the numerators by r times r plus 3. I'm going to multiply every term by that. So r times r minus 3, that is my LCD. And I will use the factored form of the denominator so we can see the pieces. And my r times r minus 3. And my equals here. R times r minus 3 times 1 over r minus 3. Now we'll clean up. So we're going to get a lot of canceling here. In the first one, that entire denominator is going to cancel. So I am left with r plus 3. In the second one, the entire denominator is going to cancel. And so I am left with r plus 4. Sorry about the color change there. And in my last one, the r minus 3 cancels, so I just have an r there. So on the left-hand side, let's put like terms together. That will give 2r plus 7. And we have an r on this side. Get the r's on the same side. So I'm going to subtract an r. 2r minus r will give me r plus 7 equals 0. Subtract your 7 from both sides. So my r will equal negative 7. Let's look back and make sure we did not throw that away. We threw away 0 and 3. So negative 7 is fine. That is our solution. For problem 23, also a solved problem because of the equals, we could do this as a proportion. I'm not going to. I really like the other technique better, and a proportion will cause you a lot of work on this one because you would have to do a FOIL. So I'm going to multiply through by the LCD. My LCD is x minus 3. Also, I need to state excluded values. The only thing that would make this denominator 0 is if x is 3. You can set it equal to 0 and solve. So we do not want to get a 3 for our final answer. Now, I'm going to multiply by x minus 3. On both of them. And it will make the denominators cancel. So what I have left is x minus 2 equals 1. And we're ready to solve. We're going to add a 2 to both sides. So I get x equals 3. So it solved nice, but we look back and we say, oh no, we threw 3 away. We can't have 3 for an answer because 3 minus 3 would give us a 0 in the denominator, something undefined. So we have to say there is no solution to this problem. For our next problem, also an equation that has some fractions. We will pick our LCD. The only denominator down there is an x, so that is going to be our LCD. for excluded values, only a 0 itself is bad. That's all that would make a 0 in the denominator. And then we will multiply through by that LCD. So we're using it on the top times each piece. You have to also do it times the 6 for it to be okay. It has to be times every single piece. And I think I'll keep my 6 first. Now we'll clean up. And so the x's will cancel. We're left with 18 equals 6x. The x's will cancel, minus 6. You have a standard two-step equation there. You're going to isolate your x. So take off the 6 that's subtracted. We'll add it. So 6x equals 24. And divide by 6. So x equals 4. We did not throw 4 away. We only threw away 0. So our solution is 4. We'll look at one more of the rational equations. And so we will pick our common denominator, where we have to have a 4 and an x. You have to have all the types of pieces. So our LCD will be 4x. For our excluded values, the 4 is okay. That is never going to be 0. So a 0 itself here or here. So x cannot be 0. We're going to multiply through by that LCD. So we're multiplying on the top, 4x times 3/4 plus our 4x times 5 over x equals our 4x times 2 over x. Now we clean up. So we're going to cancel what we can. On this one, the 4's will cancel. It leaves us 3x. On the next piece, the x's will cancel. Leaves us 4 times 5 is 20. And on this side, the x's will cancel. Leaves us 4 times 2, which is 8. Now we have a standard two-step equation. We want to isolate the x. So we're going to subtract a 20 from both sides. We get 3x equals a negative 12. And divide by 3. So we get x equals a negative 4. We threw away 0, so our answer is negative 4.